So, like I said, we're just going to kind of write it on this page because this was our practice page. It was the one that you used today. Just flip yours over to the back. Yours doesn't have anything on it. Okay. So for average atomic mass, which you'll see in your folder on Schoology, that I call it AAM, just so you know. That's what I'm talking about, AAM, average atomic mass. Do I need you to know that? No, I just don't want to, totally leave you guys hanging there. But what an average atomic mass is that's the mass on the periodic table. Okay, so your average atomic mass is that funny mass that's on the periodic table. So when we were trying to figure out mass number and I gave you guys permission to round it, that was the one that you were rounding. You were rounding your average atomic mass. So now we're going to see where that number comes from. And hopefully after you see the calculation, you'll understand why it's not the preferred way to get your mass number, because it's not really specific. It's an average, okay? So the mass on the periodic table, this is a weighted average. So you do need to write that word down. Weighted average, because biggest mistake that people make every year is they try to just take the regular average. Like you're like, okay, I have 25, I have 24, 26. I'm going to add them together, divide by 3, and I get 25, hopefully, right? So it's not a typical kind of average. It's a weighted average, just like your grades. Your tests affect your grade a lot more than a quiz does. Okay? Just like that, these isotopes and how often they occur in nature are going to affect the average. Okay? Now, I just threw the word isotope at you. So, just to kind of give you an idea of what you're dealing with isotopes. Because tomorrow you're going to get a sample kind of like this, except yours is of the element candium. All right? So you're going to be talking about 3 of the isotopes of candium. So there's Skittles, there's M&Ms, and there's Smarties. You need to get the average atomic mass of those depending on how often they were occurring in your sample. So this is what you're actually doing, right? So this one, if you kind of look very carefully, you guys don't have this picture, but look at this picture with me real quick. Okay? You know that we're talking about magnesium, okay? If you were to look it up on your periodic table, this is what you would find for the mass, 24.305. The isotopes are 24, 25, which is right here, and 26. Just looking at this, what was the most abundant isotope out of those numbers? 24, 25, or 26? 24, right? Because if you actually look at these things, 25, there's only 2 of them. 26, there's only 2 of them, and then the rest of them are all 24. So 24 definitely affects it a lot more, which is why this number is so close to 24. Okay? But isotopes mean they're kind of different flavors, right? So you guys just filled out that whole 8-man chart. You saw neutrons were coming from your mass number. Some of us had trouble with that because you're like, no, but mass is from that, and no. Okay? Your neutrons can change. They are not a guarantee. Electrons, protons, those are your guarantees, not your neutrons. So when you have a different number of neutrons, it's going to affect the weight. So the way I like to think of it is your neutrons are kind of like little pieces of fat, right? Because fat does not really contribute to your strength, but it definitely contributes to your size, right? Little fat cells. Okay, same thing here with neutrons. They're not contributing to the charge of that little atom, but they are contributing to the weight of that atom. And that's what you're going to be dealing with the candy tomorrow. So, back to this. How do we get that number? Because that'll be your ultimate goal at the end of it. You're going to write these steps down, and then I will start showing you an example. I don't recommend you write down the example. Just write down these steps right now, okay? Step 1, you're going to take your percent abundance. Okay, we're just going to write the percent. We're going to move decimal 2 spots to the left. If I move that decimal 2 spots to the left, what did I just divide it by? What number did I just divide it by if I move it 2 spots to the left? Anybody know? Not 10, but 100. So percent means out of 100. That's where that comes from. Century is 100 years, right? So percent means per 100. So we just changed it back to decimal form. All right, so we're going to do that first. Second, you're going to multiply by each isotope mass. I said isotape. Did not mean that. Isotope mass. Okay? The last step, you're going to take all those answers, you're going to add them together. Add all answers together. Okay? So you don't have to write this part, but kind of watch the process real quick. Okay? So, if I, like, for example, if I have something that has, sorry, if I have something that has 90.5%, what did that just change into with step 1? 0.905, okay? And this mass is a 20, so I'm going to multiply it by the isotope mass.
Wait, how do you get this?
It's coming from the problem, so it's going to be the isotope mass. Okay? So we're going to get that answer. Then the next one you have something that is 0.3%. So that's going to change to be 0.003. And we're going to multiply that by its mass, which is 21. You're going to get an answer there. The last one is 9.2%. So we're going to change that, 0.092. We're going to multiply that by its mass, 22. Just because I'm trying to speed through this real quick. You basically would get each of these answers, and what would you do with all of those answers together? We would add them up to get our final answer, okay? So we'll go over this problem specifically, so I'll leave those blank right now, and that way tomorrow in class we'll kind of start off with that, and then we're going to do our lab. You're going to be running through this process with your different isotopes of candium, all right? So that's what's coming. So as long as you're good there, you wrote that part down. You don't have to write this part down. If you want to just write it tomorrow, that's fine. But you guys are good. Good job today. Thank you.